I give a lecture about the latest neuroscience of hypnosis on my advanced diploma course, and as we seek to understand hypnosis more, hypnosis has actually helped us to understand the brain more in some ways too. When I first gave that lecture, I decided to purchase a model of the brain to illustrate many of my points. I found a very inexpensive one online. Here it is. I had not read the dimensions and realized that as a result why it was so cheap. Now today is not about the neuroscience of hypnosis, this video, but this video is informed by modern neuroscience. It also refers to numerous myths that are perpetuated by many in the hypnosis and related fields. Brain myths are my topic today. There are so many myths about the brain that are incredibly popular, so popular that many are considered fact by lots of people and who struggle to believe that they're even a myth when they're questioned. In this professional field and related fields, this is important. Understanding the brain and how it works is of course important to any field of mental health. Those familiar with my teaching and my work and this channel know that critical thinking is at the heart of how we do things here. And so examining the evidence to support statements that people make about the brain is also important. And therefore, I wanted to record something about brain myths for quite a while, especially as within this field, neuroscience gets cited so much these days, and very often incorrectly. Despite major technological advances in how we examine the brain, PET scans, fMRI, neuroimaging, the brain is still a great mystery. I'll also add some references in the comments section of this video on YouTube, but you can Google the evidence and studies supporting each of the points that I make here today and read for yourself too. Over the last decade, neuroscientists have shown us that many things we thought we knew about the brain are actually nothing but myths, yet many of these myths persist. Today, I'm covering some of the most common and widespread myths that have been circulating about the brain, most of which find their way into this professional field. Such as, we only use 10% of our brains. We all have preferred learning styles. We're all either left-brained or right-brained. Memory capacity is fixed and limited, and so on. A couple of others along the way. So let's get to it. Let's get on to it. Brain myth number 1. We only use 10% of our brains. According to statistics published by Wired, around 45% of teachers in the UK and 65% of teachers in the US believe this 10% myth is true. The notion is ridiculous, of course, especially when you consider that a small amount of damage can leave people with devastating long-term impairments. Or perhaps you believe that we only use 10% of our neurons at any given time. Brain scans have found that you use your entire brain pretty much all of the time. Of course, some parts of your brain are sometimes working a lot harder than others, and some people have developed better neural pathways for specialized types of thinking, such as those required for specific types of careers, sports, skill sets, and so on. Even when they're not firing action potentials themselves, our nerve cells may still be receiving signals from other neurons. The truth is that we still know relatively little about the brain and how it works, but it is highly improbable that we would have developed such a large and complex organ if it didn't provide a clear evolutionary advantage. We use virtually every part of the brain, and most of the brain is active almost all of the time. In other words, if you were to scan your brain over 24 hours, you'd find most of its regions are continually active, and over the course of the day, you would have used around 100% of your brain. So brain myth number 2 is that adults can't grow new brain cells. It's a common neuro myth. Researchers at Columbia University, for example, found evidence that healthy older adults can generate as many new brain cells as younger people. For well over a decade, research has shown that the brain is able to form new connections, a process referred to as neuroplasticity. Since then, there's been an ongoing debate over whether the aging adult human brain can also produce produce new cells, neurons. Neuroplasticity is cited by plenty of hypnotherapists and NLP practitioners these days, but it's usually explained wrongly and in a way that supports a kind of simplified and fallacious model of hypnosis. But that's a discussion for another day. In fact, a 2018 study published in the journal Cell Stem Cell shows that aging brains are capable of generating new cells, suggesting that many older adults can remain more cognitively and emotionally intact than recently believed. Brain myth number 3 is that we all have preferred learning styles. Now, neurobloggers often cite what's called the VARK model, designed by a guy called Fleming in the early 2000s, who thinks that learning styles can be split 4 ways. Visual, seeing something like PowerPoint; oral, hearing something like a lecture or audio recording; reading or writing a book, writing things down; or kinesthetic, doing stuff like an experiment or a class exercise. Unfortunately, other people, such as Caulfield and Martinez, have found and identified in the literature as many as 70 different ways of getting information in and out of the brain, which makes Fleming's model look a little underdone. And the reason it's all in your head is because regardless of what you think your preferred learning style is, there are some subjects that are best taught in a particular way. If the subject is geography, then that is maybe best done visually. If the subject is dance, and it is perhaps needed to teach that kinesthetically, and so on. So preferred learning style is pretty much irrelevant. The fact is that learning styles are subject dependent, they are teacher dependent, they are temperature dependent, they are emotionally dependent. In fact, they are dependent on so many things, they just cannot be measured. I find that many of my students and clients and professional peers who've had some NLP, some neuro-linguistic programming training, and they've learned the VAKOG model, VAKOG model of representational systems, they often draw similar conclusions about their own learning styles that are incorrect. They say stuff like, I'm a visual learner, so I need a demonstration, and I just can't learn by being taught auditorily. When they invest belief in having a preferred learning style or a dominant representational system, they're usually limiting themselves greatly and always to their own detriment, sadly. Brain myth number 4 is that we're either left-brained or right-brained. In reality, according to scientific evidence, this conceptualization is based on a complete misunderstanding of the concept of laterality, which is nothing new. The craze began when the concept of laterality was first introduced in 1978. Bryden reported that the idea initially met some skepticism. And it was the neuroscientist community that never really accepted this idea of left dominant or right dominant personality types. Lesion studies don't support it, and the truth is that it would be really inefficient for one half of the brain to consistently be more active than the other. It's an old-fashioned view of intelligence that teaches many of us early in life that we're either creative or logical. And when a 12-year-old then finds out on an online personality test that pegs her as right brain, she decides to skip maths homework because she thinks her brain is just no good at numbers. That myth becomes destructive. Our brain is not a computer. It has an amazing ability to reorganize itself by forming new connections between its different components, allowing you to continually learn new things and modify your behavior. It's one of the most complex organisms that we are aware of, and it gives you a deep wellspring for scientific thought, wild bursts of creativity, abstract reasoning, and astounding acts of love and kindness. To suggest some people are right or left-brained is simply wrong, despite how majorly well invested so many people, companies, and schools of thought are in this notion. People perpetuating this myth with self-statements such as, I am left-brained, so I'm no good at ABC, for example. They're holding themselves back with beliefs and responding behaviors, not because of any actual reality in right-brained, left-brained theory. Brain myth number 5 is that brain capacity is finite. All humans have a similar brain capacity. Many people say that they have a weak memory, but the truth is that the concept like weak memory does not really exist. I'm going to move on to memory myths in a moment. It's all about how we've trained our mind to memorize information, what strategies we use, how much belief we have in it, our state when we attempt to memorize, etc. The only difference exists in the formation of our memory, not in the integrated capacity. Our brain potential is infinite, and this leads me to a collection of brain myths that I've bunched together as memory myths, such as that memory fades with age. Many people also believe that with age they've started losing their memory, and it's true that neurons diminish with age, but memory improvement exercises, you can keep developing new cells as a result. Brain activity helps keep the memory functioning really sharp. There's much that can be done to keep one's mind sharp regardless of age. And the truth is that new learning improves memory. In many studies, it's been proven that memory works like our body muscles. The way our muscles need exercise to increase strength, similarly, our memory capacity can also be developed through brain exercise and use. Here you can use your prior knowledge to learn new information and continue to learn more and more new information. For example, the more and more you learn and use your brain, your memory capacity increases. When you learn new information and form a memory, it creates new neuron connections and strengthens your memory capacity. The human brain is designed in such a way that it's easy for us to memorize information represented in the form of a story. So learning in the form of a story which engages the imagination and encourages visualization should be encouraged for sure. Lessons should be designed in such a way that interesting characters can mimic key elements in the form of a story. Thus, metaphors and stories are effective ways for us to learn and develop. And that's good news for those of us with that type of training or that stuff included in our training. But human memory does not work like a videotape. It's a myth that once you've experienced an event and have formed a memory of it, that memory does not change. Our experiences are not perfectly recorded. We all have our own different ways to remember things, even though it's from the same lesson. In fact, each time you play it back, it could be played back differently through the filter of your mind. I've written and spoken on this subject often in relation to the therapeutic application of regression therapies and memory retrieval using hypnosis. And memory is reconstructive, and therefore it's not necessarily an accurate account of what truly occurred. Our next brain myth is that IQ cannot be changed. We now know the brain has plastic qualities, that is, it's capable of changing at any age. Since IQ is simply a measurement of cognitive skills, stronger abilities translate into higher IQ. I want to give you a quote. Our brain is more plastic than we think. This is by researcher Suzanne Yeagy. According to the research team, most IQ tests attempt to measure two types of intelligence, crystallized and fluid. Crystallized intelligence relies on existing skills, knowledge, and experience to solve problems by accessing information from our long-term memory. Fluid intelligence, on the other hand, relies on the ability to understand relationships between various concepts and to solve problems. It's independent of any previous knowledge, skill, or experience, and accesses information from our short-term memory, our working memory. And researchers have concluded that this part of intelligence can absolutely be improved. Our next brain myth is that brain size determines intelligence. Now, I joke that my huge head is actually a blessing, and I claim that it means that it houses an equally huge brain, making me more intelligent. If only. It is today well established that the cranial capacity of Homo neanderthalensis, our caveman cousin, was 150 to 200 square centimeters bigger than that of modern humans. Yet despite their larger brain, Neanderthals became extinct 40,000 years ago, while us Homo sapiens were sharing their European environment. So what's the point of having a bigger brain if your small-brained cousins outcompete you? Scientific studies across several animal species, humans included, are challenging the notion that brain size determines intelligence. Rather, scientists now tend to suggest it's a brain's underlying organization and molecular activity at its synapses, the communication junctions between neurons which nerve impulses pass, that tend to dictate intelligence. Great apes, whales, dolphins, and elephants all have the same neurons in their frontal cortex that humans have. So it's not necessarily brain size or relative brain size or absolute number of neurons that distinguishes us. It may be a more streamlined wiring, more efficient metabolism, or more sophisticated synapses, but it's probably not the size of our brain. Brain myth number 9. Alcohol kills brain cells. Now, those of you that, like myself, enjoy a drink or two here and there may be cheering right now. But it's not all good news, this one. It's not that brain cells are being killed off by excessive alcohol consumption. It's that the dendrites, which help cells communicate, they're being damaged. Alcoholics can experience brain damage related to drinking, but it's not because alcohol kills brain cells. There are a few things that can happen when people drink a lot of alcohol over a long period of time. While it can kill brain cells, it can damage the dendrites, which are the branch-like ends of the brain cells. Dendrites are key for passing messages from one neuron to another. So a degradation of the dendrites can cause cognitive problems. Recent research shows that dendrite damage can actually be reversed with certain kinds of therapy and training. Our next brain myth is that brains of males and females differ in ways that dictate our learning abilities. Differences do exist in the brains of males and females, and the distinctive physiology may result in differences in the way their brains function. No research, though, has demonstrated gender-specific differences in how networks of neurons have become connected when we learn new skills. Even if some gender differences do eventually emerge, they're likely going to be small and based on averages. In other words, they're not necessarily going to be relevant to any given individual. So why is it so easy for us to believe so many of these myths about about the brain? That there's a grain of truth running through some of them, and others seep into our own brains through repetition. And we fail to question their validity, especially when told them by teachers, trainers, or someone we trust, admire, or respect. If you previously bought into some of these brain myths, take heart. You weren't alone. Most of them are still proliferated by professionals in the hypnosis field. As much as scientists know about the human brain, there's a long way to go before we come close to fully understanding this mysterious organ that makes us human. That's it. Do subscribe to the Hypnosis Geek YouTube channel, and you'll get all the latest video updates first and automatically. And do visit my college website for information about our classroom-based and online courses. I send you my very best wishes. Goodbye for now.